Good evening. Today we will be talking about the clotting cascade. My group mates and I consist of me, Allie, Sydney, Hunter, and Lexi. Enjoy the show.
Okay, so before we start explaining the steps of the coagulation cascade, I'm going to explain what we have in our diagram so it's easier to understand. The pool noodle is our blood vessel. The red buttons here are representative of erythrocytes. The snowflakes here are the fibrin and fibrinogen. The white is the platelets. This huge button here is the end clot, and then this one, the black buttons are thrombin. Okay, I'm going to explain the first two steps to the clotting cascade. This first one over here is just a normal blood vessel with erythrocytes just flowing through normally. And then the second one over here is when the blood vessel has been broken and the erythrocytes would all be coming out. In this second one, that's where vascular spasm would start, which is where the whole entire vessel would constrict so that not as many red blood cells or anything would be flowing through. Without coagulation, we would all essentially die because you would bleed out from within. So the vasoconstriction helps to alleviate that problem. And then, okay, pause it because I don't.
Okay, so today I'm going to talk about platelet plug formation. So in the beginning of the clot formation, platelets move to the site, as you can see, where the vessel was injured. They move to the wall of the injured vessel by newly exposed collagen fibers due to the opening in the injured vessel. The platelets and the collagen come together due to the receptor in the platelet membrane, and the platelets begin to change their shape, where when they start changing their shape, they become activated. The activated platelets release adenosine diphosphate, or ADP, and the ADP binds to a receptor which activates more platelets and to the wall of the injured vessel. And then thromboxane causes the platelets to hook together, causing more platelets to invade the site of the injured vessel. This in turn starts the formation of thrombin.
Now we'll be talking about initiation of coagulation, which involves the intrinsic and extrinsic pathways. The intrinsic pathway uses factors that are found inside of the blood. It requires clotting factors 8, 9, 11, and 12, and proteins PK, which is prekallikrein, and HK, which is high molecular weight kininogen. It also involves calcium ions and phospholipids that are secreted from platelets. It is activated by trauma inside our vascular system and by platelets, exposed endothelium, chemicals, or collagen. This is slower than the extrinsic pathway. Please pause the video to see the order that the intrinsic pathway takes to create a blood clot. It can either take pathway A or pathway B, but they all end in a blood clot. The extrinsic occurs when clotting factors are released from the damaged blood vessel and perivascular tissues. This pathway uses factors from sources that are outside of the blood. The extrinsic pathway is activated by external trauma that causes blood to escape from the vascular system. This is the fastest pathway, and it involves factor 7. Okay. Pause the video to see the order that extrinsic pathway goes to create a blood clot. There is also 2 pathways for this, but they both end in a blood clot as well.
Now we will be talking about the completion of coagulation. Factor 10A has a very important role in the coagulation cascade. 1 molecule of factor 10A causes the formation of 1,000 molecules of thrombin. These large amounts of thrombin causes further activation of platelets and the enhanced formation of fibrin. Fibrin then forms strands, which helps to stabilize the platelet plug-in arterial clots. For venous clots, the venous clots are held together by red blood cells. The central role of factor 10A in the coagulation cascade makes a target for therapeutic intervention in pathologically altered blood coagulation. It takes about 3 to 6 minutes for a blood clot to form via intrinsic pathway and about 15 seconds for a clot to form via extrinsic pathway. And then this is just what the clot would look like. We have a little red button or a big button right there to symbolize the clot, and then just the buttons lining up. Fibrin, the objective is to convert the plasma protein fibrinogen, which is this one, into fibrin, this one, a sticky protein that adheres to the walls of a vessel. In order to prevent blood loss, platelets and coagulation factors working together close the wound. The resulting masses of fibrin, blood cells, and platelets seal the break in the blood vessel. Platelets are responsible for sealing the tear. Multiple coagulation factors are then activated. This causes the formation of fibrin strand stars. That stabilizes the growing clot. This complexity of clotting lies in how the fibrin is formed.
Wait, go.
So now we will be doing a mnemonic to help you guys remember the coagulation cascade. So first, for fibrinogen is freshers. And then for prothrombin is party. For thromboplastin is tonight. And I'll be sure to go over the whole thing whenever I'm done, okay? Calcium ions is come. And then for Lavallee factor is lit. I'll put that in all caps for you guys to see. Next we have stable factor, which is you sing. I'm not going to sing that for you though. We have anti-hemophilic factor A for and. Next we have Christmas factor or anti-hemophilic factor B, and we have call. I should probably get down so I don't fall. Next we have the Stewart-Prower factor for seniors. Oh wait, that's supposed to go down here. I'm a little off on the thing. This is supposed to go down there. Next we have plasma thromboplastin antecedent for please. Please give me an A on this. Next we have Hangman factor for have. And lastly, we have fibrin stabilizing factor for fun. And when you put that all together, we have freshers party tonight, come lit, sing and call seniors. Please have fun.